Okay, I'm now going to show you how to solve try these A, okay? Remember, when we're factoring these quadratics, what we're looking for is the x values of where the quadratics cross the x-axis. So it's when we're factoring and we're finding what's called the zeros of the function, that's another way of saying, like, what are the solutions to the function? It's the x values, okay? Sometimes we'll have two x values. Sometimes we'll only have one x value. Sometimes we're going to have 0, but we'll get to that a little further down the road. So it tells us to solve each quadratic function by factoring. I'm going to look at A right here. So A is x squared minus 5x minus 14 equals 0. All right, so our quadratic is in standard form, and we're going to factor it just like we learned how to factor in class. All right, so the first thing I want to do is look for a GCF. Do I have a GCF other than one that we can factor out? We don't, so we're just going to go ahead and factor using the steps that we've learned in class already. So take a look at your leading coefficient. It is a 1. You don't have to do the chart method for this one. So we can just start thinking about factors of negative 14, that's C, that add up to our middle term's coefficient, which would be negative 5. So factors of negative 14 that add up to negative 5. So I'm going to go ahead and write out my two binomials. I know that the first term in each of my binomials is going to be x. I need factors of negative 14. So let's think about factors of 14. I can do 1 and 14. I can do 2 and 7. Okay, I don't think the 1 and 14 are going to help me, but the 2 and 7, and it needs to add up to negative 5. Well, what if I make the 7 negative? All right, because if I multiply them, I get negative 14. If I add them together, I get negative 5. So that looks like a good combination. All right, so I get x plus 2, and I get x minus 7. All right. Now, we're not quite finished. We factored it, but we want to find what's called the zeros of the function. So you're going to take each one of these binomials separately, and you're going to set them equal to 0. All right? Because when we do that, we can solve for what we call the x-intercepts of the function. Okay? So I've got x plus 2 is equal to 0. Just subtract 2 on both sides, and we get x is equal to negative 2. Right here, I've got x minus 7 is equal to 0. Let me add 7 to both sides. I get x is equal to 7. Okay? So these are the two solutions. If you wrote them as ordered pairs, it would be negative 2, 0, and 7, 0. If you graphed it, let me do like a really kind of rough sketch here. 1, 2, 3, 4, 5, 6, 7. And then 1, 2, here's negative 2, here is 7. Let's see, A is positive. That means it's going to open up. So you're going to have a vertex. Oh, well, you're going to have, I know I'm going to have a y-intercept of negative 14. So that's going to be, I don't know, maybe somewhere way down. Move further down here. So it's going to hit, I don't know, maybe somewhere down here. You're going to have a vertex right around here-ish. This is just a rough sketch, folks. You can definitely check this on Desmos. All right, so your quadratic would look something about like that. But what did you just find? You found the x-intercepts of the function. Okay? All right, let's try B. Let's go to the next one. We're going to try B on try these A. So this one looks something like this. So it says 3x squared minus 6x is equal to 0. All right? Again, check for the greatest common factor. Do you have something other than one that you can factor out? Yes. Well, greatest common factor of 3 and 6 would be 3. And then what about the x? I can factor out an x as well. So I'm going to factor out 3x. All right, let's see what's left in the quadratic. I would have an x because 3x times x gives us 3x squared. And then I would have a negative 2 because 3x times negative 2 would give me negative 6x. Okay? Close my parentheses and then set it equal to 0. All right? Again, at this step, I want to take my quadratic and I want to split it into like two separate equations here. I'm going to have 3x is equal to 0. That's going to be one of my equations. And then the other one is going to be x minus 2 is equal to 0. Okay? Solve them both for x. On the first one, we're going to divide by 3 on both sides, and we get x is equal to 0. On this one, I'm going to add 2 to both sides, and I get x is equal to 2. Okay, there we go. There's my two x-intercepts. Okay, if I wrote them as ordered pairs, I would have 0, 0. And then right here, if I wrote this one as an ordered pair, it would be 2, 0. If you look at the original quadratic, you notice that there is no value for c. Right? So if there is no value for c, then it's understood that c is 0, and we know that c is always the y-intercept. Well, guess what? One of our points where it crosses the x-axis is also at the y-intercept. So if you graphed this one, you'd have one point here at the origin, okay? And then the other place where it crosses the x-axis would be right here at x is equal to 2. If you look at your coefficient of x squared, it's a 3, right? So I know that if a is greater than 1, this one's going to be a vertical stretch, which means this is going to be a real skinny function, okay? That's why it's going to be kind of a narrow, skinny function that we have going on here, all right? My vertex is going to be somewhere down here. I'm not quite sure, just right off the top of my head. I could figure it out, though, with my vertex formula. And the sides of my quadratic would come up something like that. Wow, I did a terrible job drawing that. Whoops. Sorry about that. Okay. And then let's do C, shall we? Oh, I need some more paper. Uh-oh. I tell you what, I'm just going to work it out right on here. All right. So I'm going to do C now. This is the one that I'm working on, okay? So the form of this quadratic, it is in standard form, but you notice that C is on the other side, right? C is on the other side of the equal sign. I need to move that 18 over to the left-hand side of the equal sign. And when I do that, it's going to make the 18 negative. So I get x squared plus 3x minus 18 is equal to 0. So I got to set that quadratic equal to 0. All right. Let me zoom in a little bit for you. Okay. Again, check for a GCF other than 1. 1, 3, and 18. Y'all, our GCF is going to be 1 for that. What about the x's? Does each term have an x? It does not, so we can't factor anything out. Look at your leading coefficient of x squared. It's a 1. So you don't need to do the chart method. You can go straight to factoring your quadratic into your two binomials. We want factors of negative 18 that add up to positive 3. Factors of negative 18 that add up to positive 3. So I'm going to think of factors of 18. I've got, what, 1 and 18, 2 and 9, 3 and 6. I think that 3 and 6 is going to help us out, right? I think so. So 3 and 6, if I need my last term needs to be negative, so one of those numbers needs to be negative, but my middle term, when I add them, needs to be positive. So that means my 6 needs to be positive, my 3 needs to be negative. All right, so I'm going to have, for one of my binomials, it's going to be x minus 3. For the other one, x plus 6. Take your two binomials, set them each equal to 0. Solve them for x. Okay, so add 3 to both sides. We get x is equal to 3. So this is one of my solutions. The other one, x minus 6 on both sides. So I get x is equal to negative 6. X is equal to negative 6. So if I think about graphing this one, I've got my two x-intercepts, one at 3 and one at negative 6. I also know from the function itself that my y-intercept is negative 18, so that tells me a little bit more about my function. If I did kind of a rough sketch here, let's see what this one might look like. So positive, well, let's see, 1, 2, 3, 4, 5, 6. So here's maybe negative 6, and then positive 3, negative 18. I'm not going to have enough room to come all the way down for my y-intercept, but it's going to be somewhere down here. My vertex is going to be somewhere over in here, but a little bit further down. And here would be the two sides of my parabola. I know it opens up because A is a positive number. Okay? All right, folks, you have an IXL on this one that you can practice on. If you need more help, email me, let me know.